Hello everyone. In this problem, there are several cards in a deck with point values assigned to them, represented as a list of integers. You are also given a number k, which represents the amount of cards you can choose. However, the rule is that you can only choose cards from the bottom or top of the deck at any given time. These are the right and left ends of the list you are given in code. You are guaranteed that k will be at least 1 and less than or equal to the size of the card deck. Your goal is to return an integer, which is the maximum amount of points you can get by choosing k cards. So let's look at this example here. Based on the input list, we have these cards, and because k is 3, we have 3 cards to choose from. There are multiple ways we can do this. We can always choose from the left side, or we could choose 2 cards from the left and 1 from the right, 2 from the right and 1 from the left, or all from the right. In this particular example, the best answer is option 1, which gives us the largest sum of 93. So that is what we would return. Okay, now that you hopefully understand the problem, let's take a look at the solution. The first solution is going to use recursion to mimic how a person would explore all the possibilities if they could not see the full deck of cards, but rather just the top and bottom card. We are going to make this helper function that takes in some extra parameters. First, the cards deck. Next is the remaining amount of cards we can choose from. So for our initial call, we have k cards to choose from, so we pass that in, but this will decrease by 1 as we begin to choose cards. Then we have the current left and right boundary, which represents the top and bottom of the deck. To start off, that is the leftmost card at index 0, and the rightmost card at index length -1. As we begin to choose cards, if we choose a card from the left side, we will move the left index to the right by 1. If we choose a card from the right side, we will move the right index to the left. And last, we have the current sum variable, which is the sum of the cards that have been chosen so far. For the code, the base case is when we have no more cards to choose from. When this happens, we just return the current sum because that is the only option we have. We can't pick any more cards. The recursive case is that we are going to try picking the left boundary card and picking the right boundary card, and then we choose the better of the two options. When we pick a card, we have to adjust our parameters. So the cards deck stays the same because that's just the deck of cards. We subtract 1 from the choice's left variable, symbolizing that we are choosing a card either left or right side. For the left choice, we increase the left boundary because we chose the current left boundary card. The right boundary stays the same. Opposite situation for picking the right side. When we choose the right card, the new right boundary goes to the left by 1. And finally, our updated current sum is the existing current sum plus the value assigned to the left or right card we choose. When the recursion returns back to us, we take the best or maximum of the two options and return them. Okay, now let's go to the time and space complexity. For time, it is exponential of O of 2 raised to the k. This is because for each recursive stack, we spawn 2 more recursive calls, and yes, this often causes us to solve the same subproblem, which is why it's so costly. For example, if we look at this set of inputs, we would have this recursive branching, and you can see how we are solving the same subproblem here, and this is effectively a waste of time, and I'll get to how to improve this in a moment. For space, we are using recursion, so the extra space comes from the height of the recursive stack, which can be k. Okay, now let's try and improve the exponential time complexity. Something to observe when trying to improve our solution is what are the possible ways we can pick cards. On one extreme, we can choose all the cards from the left side. The next option is all but 1 on the left and 1 from the right. Then all but 2 on the left and 2 on the right, and so on and so forth until we reach all on the right. You should notice that there are only k plus 1 ways to choose the cards, so let's devise a more simple solution that enumerates all these k plus 1 ways. Our algorithm will have 2 pointers. The left pointer will start on the right edge of the left cards we have chosen, and the right pointer will start on the left edge of the cards we are about to pick from the right side. Then we will gradually move the left pointer 1 to the left, subtracting off the left pointer's value, and at the same time, we will move the right pointer left, adding the right pointer's value. So taking a look at the code, first we have some initialization. Current total is going to be the current value of the cards chosen at any given point. So to start off, it is going to be the K left cards. We have the best total, which is the maximum current total. This is our final answer that we will return. And we have our left and right pointer. As we saw earlier, left starts on the rightmost chosen left card, which is indexed at K-1, and right starts at the next right card we are going to select, which is the right end of the deck. Then we have our for loop. This is where we start to select right cards and unselect left cards. We do this by subtracting off the left card value and adding the right card value to the current total. We then see if our new current total is better than the existing best total. And we also have to shift both the left and right pointers to the left by 1. And finally, we return the best total. That is it for the code. Let's analyze the time and space complexity. For the time, we have our 2k for loops. This means a cost of O of k, which is significantly better than the exponential 2 raised to the k in solution 1. For space, we aren't using any extra space, so that is constant. This is also an improvement from the k space in our first solution. Okay, that is it for this problem. We went over 2 solutions, a slower recursive one. We then improved to an iterative solution. Hope this video helps. Thank you for watching and good luck on all your interviews.